right, so here's another video dealing with sets and Venn diagrams and all that good stuff. So a couple ways to do this. A, union B. So think of marriage, lots of junk, right? And again, this is an or situation, so it's easy to get a lot of options when you're not picky. So when you're or, you're not picky. So it's either in one or of them, could be in both, so that would be combining of those two. So that would be what? 1, 2, 3, and 4. Okay. Intersections, see how that kind of looks like an A for and. So intersection is like overlap. So where do they overlap? So if you look, you're like, okay, they overlap. They both have 2 and 3s. So that would be your overlap. And not B would be everything in the universal set that is not B. So cross off what? 2's, I don't want 2, 3, or 4 because those are B. So not B would be 1, 5, and 6. Now again, you can also draw a picture for this. So if this is your universal set, A has 1, 2, and 3, and B has 2, 3, and 4. So what you do is you would put the overlap, okay, the intersection 2 and 3 intersect, you'd put those in the middle. A would be out here. So do you see how A has 1, 2, and 3 in it? So that's the set. B has 2, 3, and 4. So you can see 2 and 3 is also in B, and 2 and 3 is also in A. So do you see how set A has 1, 2, 3? Set B has 2, 3, 4. All right. And then the universal set has all of these numbers, 1, 2, 3, 4, 5, 6. So far I've written 1, 2, 3, 4. So that means 5 and 6 are out here. So where's the union? It would be 1, 2, 3, 4. Where's the intersection? 2 and 3. Where's not B? So if I cover up not B, so are you okay if I kind of shade this, so this, I don't want this, I want not B, then you can kind of see that, 1, 5, and 6 are not B. So that's kind of a visual representation of what we were doing over here with the math. All right, let's look at kind of more of another Venn diagram type problem. All right, so you ask people, do they have cats, do they have dogs, and do they have both? And you want to figure out different questions, like how many just have cats, how many just have dogs, how many don't have either pet. So again, if you draw your little universal set, we're going to use Venn diagrams to kind of, I don't know, tease this out a little bit. So I'm going to use C for cats and D for dogs. Notice that both. There's 6 people that have both, so I want to put those in the intersection right there because those are the people that have both. And notice they're in the cat circle and they're in the dog. Okay, so they're in the cat set and the dog set. Now, as far as have cats, that 8 is this entire set of people. So if 6 people are here, that means 2 people have to be out here to get 8 total. The dogs, there are 10 people in the dog set, but so far I have 6 of them because they also have a cat. So there's 6 people that have both. So that means there's 4, and that would give you 10. So to check your answer, the cat circle has to have 8 people in it, and the dog circle has to have 10, and then the overlap has to be 6. But notice there are 40 people total, so the universal set has to have 40 people. Well, so far I have 6 and 4 is 10, 11, 12, and so that means there's 28 people that don't have either pet. Now, there is a formula, and I'll write it up here, which is the union rule that says the number in A union B, or the cardinality, would be the number in A plus the number in B. Oopsie, sorry about that. And then you'd have to subtract the overlap. So subtract A, intersect B. And that kind of makes sense. So if you think of the people that have either cats or dogs, because remember this means or, would be all the people that have cats, which is what, 8 people. And it would be all the people that have dogs, which is 10 people. But you've double counted the people that have both, so you have to subtract it. All right, so if you look at that, 18 minus 6 is 12, which notice, do you see how those numbers do add up at 12? So that's called the union rule. We use that a lot in set theory, but also in statistics later on. All right, next one. These type of problems, you kind of have to shade where the answer is. You can either think about it, so you can kind of draw a picture and be like, okay, here's A, here's B, and I want where A with all of not B. So you could be like, okay, so this is an or situation, which is easy to shade. And so you're like, okay, I have all of A, so I'm going to shade all of A. And then I have also all of not B, so that means I'm going to shade all of the parts that are not B. Now, notice this part is shaded, and some people are like, this little piece here has to be wrong because it says not B. But see, remember, it's an or, so we have it because A has it. We don't have it because the not B doesn't have it. It's because A has it, and with or, you're putting junk together. All right, if that really bugs you, which is fine, we can kind of cheat and do color by numbers a little bit, like when you're a little kid. So 1, 2, 3, 4. And you can actually make a concept that's abstract concrete. So what is in set A? We'll call this set A, and that's a B. So set A has 1 and 2 in it. And what's in not B? So if I cross off, so not B would be what? 1 and 4? And then you can actually do the union. So union is all of it together, lots of junk. So 1, 2, and 4. So then you would shade 1, 2, and 4. So if I'm going to go ahead and put 1, 2, 3, and 4. So notice it's kind of like color by numbers. You'd shade 1, you'd shade 2, and you'd shade 4. And that's the same answer we got when we thought about it. All right, one more example here. If I have space, I might have to erase a little bit. Sometimes we can have 3 things in our set. So I'm going to go ahead and erase this to create some space here. All right, so now we have a set, but this time we have A, B, and C in it. So set A, B, and C. And again, the big one is always your universal set. All right, so here I would kind of have to think. I'd have to be like, okay, all of A with all of B, where would that intersect with the intersection of A and C? And that might get a little daunting, to say the least. So we can cheat. So 1, 2, 3, 4, 5, 6, 7, 8. So we're just putting elements in our sets. So like A has these 4 elements, B, and so forth. And I'm putting the minimal amount possible so that each region only has 1 number so that I know what to color. All right, so A union B, remember marriage, easy to get lots of junk, plus it's an or situation, so it's easy to get a lot of junk when you're not picky. So it's either in A or B, or it could be in both. All right, so that would be 1, 2, 3, 4, 5, 6. So that's the answer to that question. All right, and again, order of operations in algebra still matter. Parentheses first, this parenthesis, and then last we'll do this. All right, so this one is an and situation. This is intersection. So this is where do they overlap. So A and C. So let's see, here's what A is right here. C is right here. So they intersect at 4 and 5. Kind of running out of space here. So the last thing I do is this, but see, I have concrete numbers to do this with. And again, this is an and. This is overlap, or where intersection is the formal word. So where do these 2 sets intersect? Well, or overlap. So you can see they both have 4 and 5. So the final answer, and I'm running out of space, would be 4 and 5. So I would shade 4 and 5. So it's kind of that little almond shape right there. Now, let's see if we can kind of think this through with logic a little bit and see if that makes sense. All right, so A union B would have been all of this stuff. And A intersect C would have been all of this stuff. And then I want to know where those intersect together. Well, that's the same as what we got before. So this, now I have it solid black, would be your answer. Okay, so just a little heads up. We'll work on those in class as well, but just to kind of give you some options to think about.